In the world of cosmology and astrophysics, every now and again there comes along a discovery that completely blows our minds. From black holes to Fermi bubbles, scientists are constantly learning about the universe we live in. The universe still surprises us with new things every day. Recently, scientists have made another amazing discovery. They have discovered the first ever white hole. You heard that right. They have finally discovered the twin of the supermassive black holes, a gigantic white hole. A white hole is an alternative to a black hole, but what's so special about it? A black hole is a region of space that has such an extremely strong gravitational pull, but it can trap even light. A white hole is the exact opposite of this phenomenon. In fact, scientists didn't even know such a thing could exist until now. A white hole is essentially the opposite of a black hole because it emits matter instead of destroying it. The discovery of the first ever white hole raises new questions about how things work in the universe. Both the white and black holes are theorized as being end states for supermassive stars. Any star big enough to do this would have to be 25 times the mass of the Sun or larger, which thankfully isn't very common. Researchers from multiple research institutes have recently discovered what appears to be the first white hole ever found. To understand how it was made, you would need to understand a little about how black holes work. Astronomers believe black holes form when stars die. When a star is way more massive than the Sun exhausts its nuclear fuel, it collapses under the pull of its own gravity. This triggers a supernova explosion, which blasts the star's outer layers into space. The remaining core collapses even further under the pull of gravity, forming a compact object called a black hole. The resulting entity is a small, dense black hole that keeps sucking whatever comes near its boundary. Nothing can escape from a black hole, not even light. The boundary between which nothing can escape is called the event horizon. The closer to the center of a black hole you get, the stronger the gravitational force and the slower time passes. In fact, as you go into the center of the black hole, space changes in time and time changes in space. There are four main types of black holes: stellar, supermassive, intermediate, and miniature black hole. Stellar black holes are created when a massive star dies. Each stellar black hole is formed by a star that is 5 to several tons bigger than the Sun. Therefore, stellar black holes are incredibly dense. Because we can't see them, scientists are still looking for proof that they exist. This type of black hole is quite rare compared to the other types. Supermassive black holes are formed in the center of large galaxies, such as the Milky Way, when lots of matter falls into the core of a galaxy. This core, typically found in the center of a galaxy, is extremely dense, with a high amount of gravitational force that attracts other bodies towards it. It is similar to how a black hole is formed, but on a much larger scale. In fact, supermassive black holes can have masses that are up to several billion times greater than the Sun, making them the most massive black holes known to exist. While stellar black holes are formed when a single star collapses, and supermassive black holes are formed due to the gravitational pull of a large amount of matter in one place, intermediate black holes, as their name suggests, have a mass somewhere between the size of a supermassive black hole and a stellar black hole. The last type of black hole is the miniature black hole. These came into existence after the Big Bang. Their size is relatively smaller than the other types. In fact, they are less massive than the Sun. One thing in common for all these types of black hole: they are all created from a dying star. So one might think, will the Sun ever become a black hole? Let's have a look at this hypothesis. Well, the answer is no. The Sun cannot turn into a black hole. The reason is that for a black hole to form, the star has to be much more massive and much denser than the Sun. Since the Sun is losing its layers and burning itself up, it is not as dense as it needs to be to become a black hole. However, it will turn into another spectacular entity once it runs out of its nuclear fuel. Once the Sun runs out of hydrogen to fuse in its core, it will expand and turn into a red giant. The Sun will expand exactly 1 astronomical unit, and in doing so, it will engulf Earth, bringing an end to life on this habitable planet. This phenomenon will occur in about 5 billion years. When it turns into a red giant, it will start burning helium at its core, and this phase will last about 1 billion years. After the red giant phase, the core of the Sun will contract and become a white dwarf. This white dwarf will be roughly the size of Earth. Once the core of the Sun becomes a white dwarf, it will slowly lose mass over billions of years, shrinking and cooling and becoming a black dwarf. This is the final stage in the life of a star like the Sun. At this stage, the Sun will emit no energy and exist as a planetary nebula. Now that you have understood the phenomenon behind the formation of a black hole, you can understand how the white hole discovery is true. The concept is that a white hole would be the opposite of a black hole in that it would be a place where matter and energy could be propelled out, not sucked in as with a black hole. So when a black hole is evaporated so much to a degree that it cannot shrink further, it turns into a white hole. In other words, the constraints of space and time do not let the dying black hole suck matter any further, and so the black hole changes to a white hole and starts emitting matter. But there is a little problem here. The second law of thermodynamics contradicts the possibility of white holes. If a white hole truly existed, the second law of thermodynamics would be violated. This law states that the entropy of a closed system can never decrease. Entropy is the measure of how disorderly a system is. It is often described as the disorder in a system. A system with low entropy is very organized and orderly, while a system with high entropy is very disorganized and disorderly. A white hole would be a very orderly and controlled place, which is directly in opposition to the second law of thermodynamics. Therefore, many scientists claim that even though the existence of a white hole is possible, according to the theory of relativity, it does not exist. But wait right there. Even though scientists were not willing to accept the existence of a white hole, the universe sent a signal itself. In 2006, a powerful gamma-ray burst named GRB 060614 was observed by a NASA's Swift satellite. Initially, it was thought to be caused by a supernova. Normally, the gamma-ray bursts associated with a supernova are either long bursts or short bursts. These last for merely 2 to 30 seconds. So, the odd thing that happened in 2006 is that GRB 060614 lasted for a remarkable 102 seconds. This indicated this gamma-ray burst did not come from a supernova. In fact, it came from nowhere and collapsed on itself. There is only one possible explanation for this surprising event. GRB 060614 came from a white hole. Alon Retter and Shlomo Heller were the two astrophysicists that proposed this hypothesis. They wrote a paper explaining how GRB 060614 might have been a white hole. So what made them come to this conclusion? When Retter and Heller observed GRB 060614, they found out that the events that took place were exactly what one would expect if a white hole was to be formed. a powerful burst of energy on a large scale that scattered in the universe for some seconds and then disappeared quickly. Moreover, it came from a point that was too small to see, proving that it was indeed coming from a dense white hole that was impossible to see. This is the only explanation that makes sense about this mysterious burst of gamma rays. It is the only way that proves that white holes really do exist. And as for their purpose, this is something that scientists still have a hard time answering. What do you think about the mystery of the white hole? Let us know in the comments section below.